everyone, welcome to the 5th episode of Learn It With Me. Today we will be covering the third topic of N-level physics. This topic will be dynamics and it focuses mainly on forces. So the most fundamental force equation used is force equals to mass times acceleration. Furthermore, we can also find pressure from this original equation of force, where pressure equals to force over area. Without further ado, let's jump straight into the questions. For question 3, the diagram below shows a helicopter hovering stationary in the air. For part A, we need to draw and label two arrows to show the main forces acting on the helicopter when it is hovering. So the two arrows we need to draw are upwards and downwards. For a helicopter, it has weight, which acts downwards, and for it to hover, it needs to have lift to enable it to move upwards. For part B, you need to state what you can conclude about the size of each of these forces when the helicopter is hovering. So we need to take note that the helicopter is hovering. When the helicopter is hovering, the forces that act upwards and downwards will cancel each other. So for this, we need to conclude that the lift must be equal to the weight for the helicopter to hover. We'll do the next question, which is question 2. A moving car is pulling a trailer full of soil. So we are given two forces P and force Q, where force Q is the forward force from the engine. So for force P, it is the force acting opposite the forward force from the engine. So we can name this force as friction because of the tires which is present here. Part B, we need to describe the movement of the car and trailer when force P equals force Q. When force P equals to force Q, the equivalent forces acting on the car and the trailer are 0. This also means that the acceleration is also 0. For part C, the car has a mass of 1000 kg. The trailer and soil have a total mass of 180 kg. The car and trailer stop and then accelerate uniformly along a straight road for 6 seconds. The resultant force forwards is 2360 newtons. For this, part I, we need to calculate the acceleration of the car and trailer during this period. So we need to make use of this key formula of force equal to mass times acceleration. We are given that the mass of the car is 1000 kilograms and the mass of the trailer and soil has a total mass of 180 kilograms. So first we need to find the mass, the total mass of both the car, trailer and soil, which is 1000 plus 180 kilograms, which is 1180 kilograms. So to get our acceleration, we can rearrange the formula here to give us force over mass. And the given force that we have is 2360 newtons. And we can therefore calculate our acceleration to be 2360 newtons divided by 1180 kilograms. Which will give us an acceleration of 2 meters per second square. For part II, we need to calculate the speed of the car and trailer after 6 seconds. So acceleration formula can be given as speed over time. And we can calculate our speed by getting the acceleration multiplied with the time. Our acceleration is calculated in part 1, which is 2 meters per second square, and our time is given as 6 seconds. So 2 times 6 will give us 12. So 12 meters per second for the speed. For part D, the trailer has 2 tires. Each tire has a contact area with the road of 150 centimeters square. And we need to calculate the pressure the tires exert on the road. And the formula for pressure is force over area. So for this question, you need to take note that the force is the weight of the trailer. We are given that the trailer and soil has a total mass of 180 kilograms. So we are given with, so our weight is equal to mg, mass times gravity. So it's 180 times 10, which is 1800 newtons. Our area will be 150 cm square times 2, because we are given in the question that the trailer has 2 tires, which will give us 300 centimeters square. To complete this question, we need to substitute these values back into the equation of pressure equals to force over area. So it's 1800 newtons over 300 centimeters square. Which will give us 6 newtons per centimeter square. So we are on to the final question. The driver makes an emergency stop. The soil moves forward in the trailer. State why this happens. So when the driver makes an emergency stop, there will be momentum present in the soil. So you can say that there is momentum present in the soil, which causes the soil to move forward. Okay, so we are done with these questions for this video.